Guys, so today let's focus on sets. So what are the sets? The sets are the equations that has to do with square roots. So if you have here, let's say you have 2 plus root 3. So this is a set equation because it has a square root. Okay, so this is what we're gonna be dealing with. So they are called sets or sats. It depends on your pronunciation. So if here we have root 2 plus root 4, we're gonna learn how to add these, how to separate them, how to multiply them, okay? How to divide them as well. So these are the equations that we'll be dealing with. So here, let's start with the addition of sets. So let's have an example here. How do we add sets? So sets, we add them as in like terms. It's more like if you know how to add like terms, you're gonna know how to add sets. So if we have root 2 root 6 plus 5 root 6. So this is the example. This is the same as if you notice here, this root 6 and root 6, it makes these terms to be like terms because they have the same root 6. Okay, so this is the same as like this. If we have 2x plus 5x, you see this x here and x here, it makes these terms to be like terms, so we can easily add the like terms. As you know that we add like terms as in like, if we add 2x plus 5x, you're gonna have 7x. It's the same here. We're gonna add 2 and 7. We're gonna have 7 root 6. Okay, this is how we add the sets. So yours to do is to practice how to add sets. Okay, so what is the answer here? My answer here will be you add this 2 and this 5, you're gonna have 7. You keep the like term, you keep the root that makes these to be like terms. So we're gonna have 7 root 6. This is our answer here. Okay, we add like terms. Again, let's see now here if I can have, okay, so if I can have another example, let's say we have 3 root 7 uh, plus 5 root 7. Yeah, so if you can see here again, this root 7 and root 7, it makes these to be like terms. So we're gonna add the like terms. As you know that we are allowed to add the like terms in addition, and subtraction as well as the same thing. If we were to separate these, we're going to have 3 root 6, because 2 minus 5, it was going to be negative 3 root 6. Here it was going to be negative 2 root 6, but then we're going to have example again of subtraction. So if here where we can put as normal x, so we can have 3x plus 5x. So if you notice here, this x and x, it makes these terms to be like terms. So it's still again the same thing here, still the same thing. So we're gonna have 3 plus 5. Here is our answer here. 3 plus 5 is 8. Then we keep the root 7 as our like term. Okay, so now let's have another one. Let's have C, so that you can see how do we add the sets. So it's gonna be 7 root 3 plus okay, I said 7 root 3. Then again, it's gonna be 4 root 3. Okay. So here, if you notice again, this root 3 and root 3 here, it makes these terms to be like terms. So it's still the same as 7x plus 4x, if you know in algebra. So this x and x, it makes these to be like terms. So it's when you add 7 plus 4, you're gonna have 11x. Okay, so now let's see what we can do. What we can do when we add these. So always when you find these, you add them like this. So 7 root 3 plus 4 root 3 is equal to 11 root 3. So this is your answer. This was addition of sets. Addition of sets. Then now let's come to the subtraction of sets. Subtraction of sets. Okay, it's still the same thing. If we're gonna use the same examples there. So if we have 2 root 6 minus 5 root 6, you're gonna have 2 I'm sorry for that. So 2 minus 5, it's gonna be okay. Here, to avoid the negative number, let's start with the bigger number, with a bigger term. So 5 root 6 minus 2 root 6. 5 minus 2 is equal to 3 root 6. You see, it's the same thing. B 3 root 7. Okay, we said we start with a bigger number or with a bigger term so that we can avoid the minus. So 5 root 7 minus 3 root 7. Then 5 minus 3, it's gonna be 2. Then we keep the root 7. Then we come again here, which is the last example. Root 7 root 3, sorry, minus 4 root 3. My apologies for the alarm. It's just an emergency around. Okay, 7 root 3 minus 4 root 3. Then 7 minus 4, it's gonna be 3 root 3. This is the answer. Okay, so this is how we deal with the sets. In addition and subtraction is the same thing. Okay, so this is how you deal with sets. Let's talk about now these way to summarize everything. These way addition of like sets, subtraction of like sets. So let's say now these are unlike terms, so they are unlike sets. So if they are unlike sets, they are the same. You keep the same. So let's say here we have, okay, unlike sets. Now I'm gonna write here unlike sets. How do you deal with the unlike sets? So unlike sets, you deal them like the normal method, in the addition of unlike term. So if you have 2 root 6 plus 5 root 8, so what is the answer here? You keep it the same because you can't add the unlike terms. So these are unlike terms because they have different roots. So root 6 and root 8 are unlike terms. So you keep these the same, still the same answer. Okay. Then even here, if you have, for example, here, unlike sets again here, if you have here, let's take B. Here we took A. So here we can take B. So if you have root 5 root 7 minus 3 root 4, that means now these are unlike sets. So root 7 and root 4 are unlike sets. So we can't do anything. So it's the same problem. So this is how you solve this. This is how you solve this. Okay? So it's more like the same problem that you were given. So it doesn't get affected if it's unlike sets. But then if it's like sets, you can add, you can subtract. Okay? So now we're gonna move to the multiplication of sets. So let's move to the multiplication of sets and see how do we multiply sets. Okay, so hopefully the alarm is not disturbing. I'm trying by all means to be loud. It was unexpected. Multiplication of sets. So in the multiplication it's a little bit different. So this is what we will be dealing with. I'm gonna first write the rules. Number 1, if we have this rule, root A multiplied by root B, what is it gonna be? It's the same as root AB. Okay? So both of these will be A greater than 0, B greater than 0, because all the numbers that are under the square roots, they are not supposed to be negative. If it's in a negative number under the square root, it's undefined or it's a math error. So you can't have a negative number under the square root. Hence why you keep your A greater than 0 and your B greater than 0. So let me make an example here. What do I mean if I say if I put this general rule here or principle? So let me say here it's principle 1. So if here I have root 4 multiplied by root 3, it means I'm gonna have 4 multiplied by 3, then that's gonna be root 12. If you can use your calculator, you can multiply, you can say root 4 multiplied by root 3. You're gonna have root 12, not root 12 necessarily, but then we're gonna simplify it further in this case. So we're gonna simplify it further. So we're gonna give the square root of this 4. which is gonna be 2. Then you will be left with the root. Okay, this is how this thing happened. Let me not confuse you. If you are in this case, you are in this kind of problem. So you have here root 4 multiplied by root 2 is equal to 4 multiplied by 3. It ends here. It doesn't go to 12. Okay. Now that this one has its root, so you can simplify it further and say, what is the root of 4? It's 2. You take it outside. Then you are left with 3 inside. Okay. Or it's still the same thing here. If you want to simplify it further, you can write the root of this, then you multiply with the, I said here root, I said 3. It's 3 here, not 2. So you can make sure that you have this. So what I'm saying is that the square root of 4, it's 2. Then you leave with this one doesn't have a square root, so you leave it like this. Then 2 multiplied by root 3, it's gonna be root 2 multiplied 2 root 3 like this. So this will be your answer. Multiplication of sets. So let me repeat this. If it's not clear, let me repeat it again. What I'm saying is that there's a principle, which is principle 1. It says, if you have root A multiplied by root B, it's gonna be root AB, where A is greater than 0 and B is greater than 0. They are both not negative, they are positive. So I'm making an example now. This is my example here. This is my example. So I'm making an example here. I have root 4 multiplied by root 3. That means it's gonna be 4 multiplied by 3 here. Okay, this is the principle. But now what you can do is that you can even go further and but I think in your level you only end here, but then you can go further and just not write this one, but ask for the root. What is the square root of this? It's 2. Then you write that one because it doesn't have a square root. Then you are left with 2. Then you can have 2 root 3, because 2 multiplied by root 3 is 2 root 3. So this must be your answer. The calculator will give you this simplified answer, but then this one is still the same thing as well. So if you are using a calculator, click this on the calculator, say root 4 multiplied by 3. No, not root 4, but square root, then 4 multiplied by 3. You're gonna get this. Né? So if you simplify it further, it's gonna be 2 root 3. But I was just showing you how did it come there. How is it simplified? So it is simplified based on this. So root 4 has a square root 2. 3 doesn't have a square root, so it's root 3. Then 2 multiplied by root 3, it's 2 root 3. Okay? This is how it's done. Then now, let's come to another principle. Principle 2. So in principle 2, if you have now a square root, then it's multiplied. It's squared like this. It means is equal to root a multiplied by root a as normal, right? So what is the square root? Okay, let's put it like this. But then what I want to emphasize is that if you are given a square root like this, a problem like this, then your answer will be A. Okay? Then where A is always greater than 0, because A can never be negative under the square root. So you make sure that the number that is under the square root is negative. So this is the principle that you should have. And also, if you multiply this root and this root, when you multiply both of them, they will cancel. Okay? Then you will be left with A here. Still the same thing here. If you have root and then A squared, then it's gonna be A here. Okay? But then if you have A only, not squared, it's not gonna be A, it's gonna be root A. So what I'm saying is that if you come to numbers now, you have root 2 multiplied by root 2, then you're gonna have 2, because this root and this root will cancel, then we leave these 2. Okay, this is what you should know here. This is the principle. So the principle says if you have a that is squared, if you want to remove the square root, just square it, then it's going to be removed. As you can see here, this root and this root, when they are multiplied together, they will be removed and leaving what is inside the square root. So this one as well, root 2 multiplied by root 2 is going to leave 2. Hence why when we remove the square root, we just square like this. So when we want to remove the square root, we just square like this. So what will be left here is 2. Okay? So this is what you should know here as multiplication. Okay, so let's come to the examples now, example questions. Let's say we have here our A, 5 multiplied by root 7. What is the answer here? 5 multiplied by root 7, it's going to be 5 root 7. Okay? Then B, what is B? So our B will be 3 root 5 multiplied by root 2. What will be the answer? So we said that if you have 2 roots, then you combine 2 numbers inside. In principle 1, you have 2 roots, then you combine 2 numbers inside. So you're going to keep these 2, these 3, but then you combine these numbers inside. Because the principle 1 says if you have 2 roots, you multiply them, then you will take these 2 different numbers inside. But here you only only happen when you have 2 like terms. The numbers when they are like term. So you have 2 multiplied, root 2 multiplied by 2, root 2 is gonna be 2. But then here you have root 4 multiplied by root 3. So it can't be removed because these numbers are not like terms, they're unlike terms. So hence why here again we are combining these ones because are unlike terms. If they were like terms, if you were having root 5 multiplied by root 5, we are going to have only 5 here, which is 3 multiplied by 5 is it was going to be 15. So we keep these 3, then 5 multiplied by 2, it's going to be 10. This must be our answer here because we multiplied what is inside there. So 10 doesn't have a square root, so it will remain like that. So if we can have again another one, C, then we have root 3, then all squared. Then what does it mean to you? It means that the square root was removed. So if we expand this, it's going to be like this. Then root 3 multiplied by root 3, it's going to be 3 because this root and this root is removed because these are like terms and there is a multiplication. So the square root is removed when the terms are the same inside the square root. So you'll be left with this one number. So here it's going to be 3. This is your answer. Then now let's come to this one and see. This is principle 2 here. Okay, we use principle 2. So again, let's have this one 5, then which is 5 root 2, then all squared. What is this one now? It means now you're gonna have 5 root 2 multiplied by 5 root 2. It means 5 multiplied by 5 is gonna be 25. Then root 2 multiplied by root 2, it's gonna be 2 because it's removed, right? Then now your answer will be, okay, let me write it here. Your answer will be 2 multiplied by 25, it's 50. This must be your final answer. Okay? Now you followed principle 2 in all of your steps. But then this was inside the brackets as well, this 5. So it has to be multiplied as well. Okay, so now let's have E, D. Okay, we are done now doing the multiplication, but let's go to the division now of these. Okay, we said multiplication of sets. Then now we are dividing the sets, division of sets. Remember, we don't leave the principles that we learned from multiplication. If we are on sets, it doesn't mean that if we are on division, it doesn't mean that we leave the multiplication of sets. So we continue with the principles that we know from the multiplication, even if we are in the division. So okay, here let's have our first example of division. So if I have 2 multiplied by root 5, then divide by negative 3 multiplied by root 5. What will I have here? So 2 multiplied by root 5 is 2 root 5. Then negative 3 multiplied by root 5, it's going to be negative 3 root 5. Okay? Now we are doing the multiplication, but we are in the division. So what does it mean to you now? It means that this root 5 and this root 5 will divide and cancel. Then you will be left with 2 divided by negative 3. Therefore, it's like this. The fraction is written like this. Okay, this must be your answer there. Then again, we go to the last example of this. So if we have 2 plus root 2. So I said to you, for you to add the fractions, you must make sure that your denominators are the same. So if you can see here, we have an invisible denominator, which is 1. So these denominators are not the same. So in the addition of fractions, we must make sure that the denominators are the same so that we can add the numerators. Eh? So now what we're going to do, we're going to make these denominators to be the same. So I'm going to multiply by, okay, I'm going to multiply by root 2 here. 1 multiplied by root 2 plus, then I'm going to multiply by 1 on this side, on the left hand side. You see now our denominators are the same because I took this 1, I multiplied by here, then I took this root 2, I multiplied by here on 1. But then what you did on the denominator, you must do on the numerator. So I multiply by root 2 here, then I will multiply by root 2 here. Then here again on the numerator, I multiply by 1. I will multiply by 1 because on the denominator I multiplied by 1 so that the denominators can be the same. So that means if we can now continue, this is 2 multiplied by root 2, it's going to be 2 root 2. Then 1 multiplied by root 2, it's going to be root 2. Then 2 multiplied by 1, it's going to be 2. Then 1 multiplied by root 2 is root 2. So now we see how is our method of adding fractions. So I'm still gonna share the lesson of addition of fractions and subtraction of fractions so that you can see. So now we can add our numerators because we have two, like our denominators are the same, so we can add the numerators, we are allowed. So 2 plus root 2, so obviously these are unlike terms, so it's gonna be 2 plus 2 root 2, then root 2 like this. You see, so this must be our final answer because these are unlike terms, so obviously they are not gonna add. So this is how we do the sets. So if you don't understand the principles, make sure that you understand these principles and make sure that you understand the addition of like terms and unlike terms. And also the multiplication. If you have unlike terms in the square root, then you combine the two numbers under the square root. Then if you have two like terms under the square root, you cancel the square roots, then you have that number. We have that number, one number that is the same. So if you can see here, root 2 multiplied by root 2 is 2. Because we cancel this root and this root, we are left with 2. But here, these are unlike terms. Root 4 are multiplied by root 3. So we took these two numbers, we put under the square root, 4 multiplied by 3. Then we can have, now we can go both, we can break them down, that this one has a root, it has root 2, so we take it aside. Then you leave the 3 inside the square root, because this 3 doesn't have a square root. I made an example here. How does this happen? So this root 4 is a square root, so its square root is 2, but this one doesn't have a square root, its square root is 3. It doesn't have a square root, so now it's root 3. Then 2 multiplied by root 3, it's going to be 2 root 3. Okay, hence why now in the calculator, if you put this inside the calculator, then you're going to have this. That's how it's done. Then the rest you follow. These are the examples that you must have, that we were doing. They are simple like this because we follow the principles and we follow the addition and the subtraction of like terms and unlike terms. Then this will be the end of our lesson. Then we're still gonna continue with the addition of fractions so that you can see how do we add the fractions and subtract the fractions.